Here I have this fractional expression where I have complex numbers in both the numerator and the denominator, but I can't have an I in the denominator, so I have to do my process of rationalizing my denominator. So I'm going to multiply the top and the bottom by this complex conjugate, so I have -6 and I, but instead of a plus sign, I have a minus sign. So I'm going to multiply the top and bottom of this expression by -6 minus I. So I'm going to go ahead and put parentheses around everything because I know this means I have to multiply all this stuff together. So my numerator is just going to be a process of distribution here. So 5 times -6 is -30. 5 times -I is -5I. -2I and -6 is going to be a positive 12I. And then -2I and -I will be positive 2I squared. Okay, so all that's being divided now. And remember, the reason we do these complex conjugates this way is because it sets up a difference of squares factorization, where I'm going to do the firsts and the lasts, because all the middle terms cancel anyway. So -6 times -6 is 36, and then minus I squared. Well, remember that I squared is going to be -1, so this guy is going to be -1 as well, which means my denominator, when I swoosh swoosh here, subtract a -1, is going to be 36 plus 1 is going to be 37 for my denominator. And my numerator here, I have some like terms here, so -5I and 12I is going to be 7I, so plus 7I. And then when I have this 2 times -1, this is a -2. And then -30 and -2 makes -32 plus 7I all over 37. But I have to divide these numerators apart and split this denominator. So it can be an A plus BI form. Just like that, where my real part comes first and my imaginary part comes second, and the coefficient of my imaginary part, B, comes separately and before my I.